Imagine staring up at the night sky, those countless pinpricks of light, the vast emptiness between them, and realizing everything you see might be a lie. Space isn't just the final frontier, it's a hall of mirrors, bending reality in ways that make even the wildest science fiction seem tame. What if I told you black holes could be conscious, watching us back? Or that our universe might be one of countless others, each with its own laws of physics, its own versions of you. These aren't plot twists from a movie. They're real theories backed by some of the brightest minds in science, and they're about to rewrite everything you thought you knew. We like to believe we've got the universe figured out. Planets orbit stars, gravity keeps us grounded, and time moves in one direction. But peel back the curtain and you'll find a cosmos teeming with mysteries that laugh at our puny human logic. Take dark matter, for instance, invisible, undetectable, yet making up most of the universe's mass. Or quantum entanglement, where particles millions of light-years apart react instantly to each other, as if space and time don't exist. These aren't just quirks, they're clues that reality might be stranger, grander, and more terrifying than we ever imagined. That's why today's journey is so thrilling. We're diving into 30 of the most bizarre, mind-bending space theories that challenge the very fabric of existence. From the idea that we're living in a simulated universe to the possibility that time itself is an illusion, each one will stretch your imagination to its limits. Some will sound like pure fantasy until you hear the evidence. Others will make you question whether we're even asking the right questions, so buckle up. By the end of this, the night sky won't look the same, and neither will you. What if everything around you, the stars, the trees, even the screen you're staring at right now, wasn't real? Not in the philosophical sense, but literally. A growing number of physicists, philosophers, and tech billionaires are seriously considering the possibility that our universe might be nothing more than an ultra-advanced computer simulation. Think of it like the most immersive video game ever created, except with the characters blissfully unaware we're living in code. This wild idea, known as the simulation hypothesis, isn't just science fiction. Philosopher Nick Bostrom laid out a chilling trilemma that forces us to confront three unsettling possibilities. Either one, nearly all civilizations go extinct before developing the tech to run realistic simulations. 2, advanced civilizations lose interest in creating simulated realities. Or 3, and this is the spine-tingling one, we're almost certainly living in a simulation right now. Why? Because if even one civilization ever reaches the point of creating conscious artificial worlds, they'd likely make billions of them, dwarfing the single, real universe. Statistically, the odds aren't in our favor, but what about hard evidence? Some scientists point to strange glitches in the fabric of reality itself. At the quantum level, particles behave in ways that eerily resemble computer processing. They exist in multiple states at once, like a program rendering only what's being observed until they're measured when they suddenly choose a position. Even the fabric of space-time might have a resolution limit, a smallest possible unit, much like pixels on a screen. The Planck length, the tiniest measurable distance in physics, could be the universe's equivalent of a code boundary. Elon Musk famously put the odds at 1 billion to 1 that we're in base reality. His reasoning: look at how far video games have come in just 50 years, from Pong to photorealistic virtual worlds. Extrapolate that over thousands or millions of years, and simulations would become indistinguishable from reality. If that's true, who's running the simulation? An advanced civilization, a future version of humanity, or something we can't even comprehend? The unsettling beauty of this theory is that it can't be disproven. After all, any evidence we find could just be part of the simulation script. So the next time your phone glitches or déjà vu hits, maybe it's not your imagination. Maybe it's the universe buffering. Hold onto your seat for this next one. It makes the simulation theory seem downright cozy by comparison. Picture a lone brain, perfectly formed, complete with memories and thoughts, spontaneously materializing in the emptiness of space. Not attached to a body, not orbiting a star, just floating there, utterly convinced it's a real person living a real life. That's the nightmare fuel known as the Boltzmann Brain paradox, and it's not just a sci-fi plot twist, it's a legitimate puzzle that keeps physicists awake at night. The idea comes from an unsettling quirk of thermodynamics. Over infinite time, random quantum fluctuations could theoretically arrange particles into any configuration, no matter how improbable. Statistically, given enough time, these fluctuations might accidentally assemble a fully conscious brain, complete with fabricated memories of a past that never existed, rather than an entire universe like ours. In fact, according to the math, isolated Boltzmann brains should outnumber real observers like us by an unimaginable margin. So why do we find ourselves in a universe with galaxies, planets, and history books instead of drifting alone in the void? This isn't just a fun thought experiment, it's a crisis for cosmology. If Boltzmann brains are more likely than ordinary observers, why doesn't our reality match the prediction? Some argue it undermines our entire understanding of time and entropy. Others suggest it's evidence we're missing a fundamental law of physics, one that prevents such freak occurrences. A few even propose we might be Boltzmann brains, hallucinating the cosmos in a fleeting moment before dissolving back into chaos. The real kicker, there's no way to disprove it. If a Boltzmann brain hallucinates an apple falling from a tree, would Newton ever know the difference? This paradox forces us to confront the fragile nature of perception. Everything you remember, everything you trust as real, could be a phantom narrative woven by random particles in an indifferent universe. It's enough to make you question whether the screen you're watching right now is even there. If black holes are the universe's ultimate vacuum cleaners, sucking in everything that crosses their path, then white holes are their rebellious twins, cosmic fire hydrants blasting matter outward at impossible speeds. These theoretical monsters are the exact opposite of their dark siblings. Where nothing escapes a black hole, nothing can enter a white hole. They're like cosmic one-way valves, violently ejecting energy and matter into space while slamming the door shut behind them. And here's where it gets wild. Some physicists argue the Big Bang itself might have been the mother of all white hole explosions. Think about it. The Big Bang wasn't just an expansion of space, it was a sudden, incomprehensible eruption of matter and energy from, well, nowhere, no center, no pre-existing space, just a singularity bursting into existence. That sounds eerily like what a white hole would do. If this theory holds, our entire universe could be the aftermath of a white hole's final, spectacular tantrum. A single point of infinite density vomiting up reality as we know it. This flips standard cosmology on its head. Instead of a smooth, uniform expansion from a hot, dense state, the white hole model suggests a violent, uneven birth. It could explain why some corners of the universe seem oddly lopsided, with mysterious, cold spots and clumps of galaxies that shouldn't exist if the Big Bang was perfectly symmetrical. Maybe those aren't imperfections, maybe they're cosmic scars from the white hole's chaotic outburst. But here's the catch. White holes violate the second law of thermodynamics, which says entropy always increases. A white hole would essentially be a cosmic reset button, spraying order into the universe like a shaken soda can. That's why many physicists dismiss them as mathematical curiosities, beautiful in theory, impossible in practice. Except, what if the Big Bang was the exception? A single, universe-defining moment where the rules bent backward. The strangest twist, if white holes exist, they might not be ancient relics. Some theories suggest microscopic white holes could pop into existence right now, somewhere in deep space, spitting out brand new particles before vanishing. Imagine stumbling across one, a tiny, shimmering wound in space-time, gushing matter like a waterfall in reverse. It's the kind of cosmic magic that makes you wonder, if the universe began with a white hole, could it end with one too? What if we're all just shadows on the cosmic wall? That's the bizarre implication of the holographic principle, a theory so radical it redefines the very nature of reality. Think of the universe like a movie projected onto a giant screen, except the screen is a two-dimensional surface at the edge of space, and we're the three-dimensional illusion playing out on it. This isn't some trippy metaphor, it's a serious hypothesis born from the study of black holes, suggesting that everything we see, touch, and experience might be encoded on a flat boundary we can't perceive. The idea took root when physicists studying black holes stumbled on a paradox. These cosmic vacuum cleaners seem to destroy information, which violates the fundamental laws of quantum mechanics. But what if the information isn't lost? What if it's smeared across the black hole's event horizon like a cosmic fingerprint? That's the essence of the black hole information paradox. The event horizon, the point of no return, might act like a colossal hard drive, storing every bit of data about the objects that fall in. And here's where it gets mind-blowing. If a black hole's surface can encode information, maybe the entire universe works the same way. The holographic principle takes this further, proposing that all the information needed to describe our 3D reality, every star, every thought, every moment, could fit onto a 2D surface at the universe's edge. It's like realizing your favorite video game isn't built in 3 dimensions. It's just pixels on a flat screen creating the illusion of depth. This would mean space, with all its volume and texture, is an emergent property, a trick played by the underlying code. Even your sense of free will could be part of the illusion, predetermined by data written on some distant cosmic boundary. Skeptics argue this sounds more like philosophy than physics, but the math holds up. In the 1990s, physicist Leonard Susskind and others showed that string theory calculations align eerily well with holographic models, and experiments with quantum gravity, like those at Fermilab, hint that spacetime might indeed be pixelated at the tiniest scales, just like a hologram's grainy surface. So where does that leave us? If the holographic principle is true, reality is a performance, and we're the audience and the actors, trapped in a cosmic theater we don't fully understand. It's humbling, terrifying, and exhilarating all at once, because if this theory's correct, the universe isn't just stranger than we imagine, it's stranger than we can imagine. History as we know it might be nothing more than an elaborate forgery, a grand illusion spanning centuries. The phantom time hypothesis suggests nearly 300 years of the past never actually happened. According to this radical theory, the period between 614 and 911 AD was entirely fabricated, inserted into the timeline by powerful rulers or institutions for reasons lost to time. If true, we're living not in the year 2024 but closer to 1727, and everything from Charlemagne's empire to the Viking Age could be part of an intricate hoax. The idea was first proposed by German historian Heribert Illig, who noticed strange inconsistencies in the historical record. Medieval documents from this era are suspiciously scarce, and architectural styles seem to leap forward without gradual evolution. Even celestial mechanics hint at something amiss. Eclipse records from that period don't align with modern astronomical calculations unless you remove those phantom centuries entirely. Carbon dating adds another layer of mystery. Some artifacts supposedly from the 7th to 10th centuries show chemical compositions more consistent with later periods, as if history's clock was artificially stretched. But why would anyone fake hundreds of years? One chilling possibility involves Emperor Otto III and Pope Sylvester II. In this scenario, they conspired to rewrite time itself, backdating events to position Rome as the spiritual heir of ancient empires. Others speculate it was a massive clerical error. medieval scribes misinterpreting dating systems, compounding over generations until the timeline warped beyond recognition. The implications for cosmology are staggering. If those 300 years never occurred, our measurements of celestial events, supernova, planetary alignments, even the age of the universe could be fundamentally skewed. The light from distant stars would have traveled less time than we think, redrawing the cosmic map in ways we can't yet grasp. Skeptics dismiss the theory as pseudo-history, pointing to tree rings and ice cores that show annual layers matching the conventional timeline. Yet the tantalizing question remains: if time can bend around black holes and warp at relativistic speeds, who's to say it couldn't be manipulated in the pages of history itself? We may never know for sure whether the early Middle Ages were real or an elaborate fiction, but the possibility alone unravels our trust in time's steady march. Forget everything you've been taught about gravity ruling the cosmos. What if the real puppet master behind galaxies, stars, and even life itself isn't some invisible force, but electricity? That's the radical claim of the electric universe theory, a fringe idea that throws standard astrophysics out the window. Instead of dark matter, black holes, and cosmic inflation, this model paints the universe as a vast, interconnected circuit where colossal electric currents sculpt everything from spiral galaxies to solar flares. And the implications are shocking enough to make Newton's apple float. At the heart of this theory lies plasma cosmology, the study of ionized gas or plasma, which makes up over 99% of the visible universe. While mainstream science treats plasma as just another state of matter, electric universe proponents see it as the cosmic glue. Imagine filaments of supercharged plasma stretching across billions of light years, twisting into galaxies like glowing snakes. These filaments, they argue, carry electric currents strong enough to shape entire galactic structures without needing dark matter's gravitational crutch. It's a vision of the cosmos where magnetism and electricity do the heavy lifting, not some mysterious, undetectable substance. Take galaxy formation, for example. Standard models rely on dark matter's gravitational pull to explain why galaxies don't tear themselves apart as they spin. But plasma cosmology offers a wild alternative: Birkeland currents. Named after Norwegian scientist Christian Birkeland, these are massive, paired streams of charged particles that spiral through space, creating magnetic fields powerful enough to hold galaxies together. Snap a photo of a distant galaxy, and those elegant spiral arms might not be gravity's handiwork. They could be the scars of million light-year-long lightning bolts. Even our own solar system shows eerie hints of an electric past. Saturn's strange hexagon storm. Electric universe theorists say it's a plasma discharge pattern. Jupiter's roaring auroras, cosmic currents tapping the gas giant like a battery. Some go further, suggesting ancient humans witnessed these celestial fireworks, that myths of thunderbolts and dragon serpents were primitive descriptions of interstellar plasma discharges visible from Earth. So why doesn't mainstream science embrace this electrifying idea? Critics point to glaring gaps. The theory lacks precise mathematical frameworks to match gravity's predictive power, and no lab has recreated galaxy-scale plasma structures. Worse, it struggles to explain phenomena like the cosmic microwave background, the afterglow of the Big Bang, without resorting to ad hoc fixes. But the boldest electric universe advocates fire back. Maybe we're the ones trapped in an outdated paradigm, clinging to dark matter like medieval astronomers insisting the sun revolved around Earth. Whether it's revolutionary truth or captivating pseudoscience, one thing's certain: the electric universe theory jolts us awake to the possibility that we've underestimated the cosmos's raw, crackling power. And if even a fraction of its claims hold water, we might need to rewrite the universe's instruction manual, with sparks flying on every page. The Big Bang wasn't a beginning, it was a rebirth. That's the spine-tingling promise of the Big Bounce theory, a radical rewrite of cosmic history where the universe doesn't just expand and fade away. It collapses, rebounds, and begins anew in an endless cycle of creation and destruction. Picture a cosmic accordion, squeezing down to an unimaginable density before springing back outward in a fresh explosion of matter and energy. No fiery singularity marking time zero, no void before existence, just an infinite loop of universes, each inheriting echoes of the last. This isn't just poetic speculation, it's hard physics. Quantum gravity models like loop quantum cosmology suggest spacetime might resist collapsing into a true singularity. Instead, as the universe contracts, quantum effects could generate a repulsive force so powerful it halts the crush and triggers a rebound. Think of it like compressing a spring to its limit, pushed too far, and it snaps back with equal fury. In this scenario, the Big Bang wasn't the start of everything. It was the moment our universe bounced back from a previous one's death throes. The implications shatter our linear view of time. If the Big Bounce is real, the cosmos has no true beginning or end, only phases. Galaxies, stars, even life itself might have existed countless times before, evolving in slightly different ways with each iteration. Ancient light from the cosmic microwave background could carry faint fingerprints of a prior universe's structure, like shadows on the wall of a reborn world. Some physicists even suggest black holes might serve as cosmic seeds, their interiors birthing new universes with altered physical constants, meaning our own laws of nature could be inherited quirks from a long-gone ancestor cosmos. But how do we test such a mind-bending idea? Clues might lie in the universe's geometry. A bouncing model predicts subtle differences in how spacetime stretches during each cycle, potentially leaving detectable wrinkles in the distribution of galaxies. Others hunt for anomalies in the cosmic microwave background, patterns that shouldn't exist if our universe had a singular, fiery birth, the real kicker. If the Big Bounce is correct, every atom in your body has already lived this story infinite times before. You've laughed, loved, and wondered at the stars in universes past, and if the cycle holds, you'll do it all again. Critics argue the theory dances too close to metaphysics, with no mechanism yet explaining how information survives the crushing reboot. Yet its haunting beauty lingers, a universe forever renewing itself, turning its own death into the raw material for new beginnings. After all, if stars can be reborn from stellar ashes, why not the cosmos itself? The Big Bounce doesn't just challenge our origin story, it whispers that endings might be the most creative forces in existence. Every choice you've ever made, every path taken or ignored might not just exist as a fleeting thought. It could be playing out in full, vivid reality somewhere else in the cosmos. Welcome to the Multiverse, a mind-bending maze of infinite parallel universes where every possible version of you lives every possible life. This isn't science fiction. It's a legitimate interpretation of quantum mechanics, one that suggests reality isn't a single thread but an unfathomable tapestry of alternate timelines, each as real as our own. At the heart of this madness lies the many worlds interpretation, a theory as elegant as it is unsettling. When quantum particles face a choice, like whether to spin left or right, they don't actually choose. Instead, the universe splits, branching into two separate realities where each outcome occurs. Apply this to every quantum event, every decision, every random fluctuation, and you get an exponentially growing tree of universes. In one branch, you clicked on this video. In another, you scrolled past. Somewhere out there, a version of you is already living the consequences of both. The eerie part, according to the math, these branches aren't hypothetical, they're as concrete as the world you're experiencing right now. But the multiverse doesn't stop there. Imagine space itself boiling like a cosmic pot of water, with new universes constantly bubbling into existence. This is eternal inflation, a theory suggesting our universe is just one frothy bubble in an endless foam of others. Each bubble has its own unique physics, some with stronger gravity, some where light moves slower, some where life never got a foothold. Most would be inhospitable to us, but in an infinite multiverse, even the wildest possibilities like a universe made entirely of sentient chocolate must exist somewhere. The implications are dizzying. Every time you flip a coin, the universe doesn't just resolve it heads or tails. It spawns two new timelines where both outcomes are real. Every historical event, from the rise of empires to the fall of meteors, plays out in infinite variations. There's a world where dinosaurs never went extinct, where the Library of Alexandria still stands, where you're the one making this video instead of watching it. Critics argue this is less science and more metaphysics, an untestable idea that explains everything but proves nothing. Yet supporters point to quantum experiments showing particles influencing each other across impossible distances, as if ghost versions of reality are leaking through. Some even suggest black holes could be gateways to these alternate worlds, their crushing gravity warping space-time so severely that other universes press against the edges. Whether you find it liberating or terrifying, the multiverse forces a humbling realization. Reality might not just be stranger than we imagine, but stranger than we can imagine. So the next time you hesitate at a crossroads, take comfort or shudder knowing another version of you didn't, and they're out there right now living the consequences. Time doesn't march forward, it spirals, looping back on itself in an endless, predetermined dance. This is the chilling elegance of the time loop universe theory, where every moment you've lived, every breath you've taken, is destined to replay exactly as before forever. Forget linear history, forget free will. This model suggests the universe is a broken record, eternally resetting at the heat death of existence and starting the same song over from the beginning. The idea traces back to Friedrich Nietzsche's concept of eternal recurrence, but modern physics gives it terrifying teeth. If entropy, the universe's inevitable slide into disorder, somehow resets at maximum chaos, all particles could return to their original positions, recreating the Big Bang's conditions with perfect precision. Picture a cosmic pendulum swinging from explosive birth to icy death, only to be pulled back by unseen forces for another identical cycle. In this scenario, you've already read this sentence infinite times before, and you'll read it infinite times again with no memory of the repetition. Quantum mechanics adds eerie credence to this. At microscopic scales, particles don't experience time linearly. They oscillate between states in ways that defy cause and effect. Some interpretations suggest time's arrow might be an illusion, a byproduct of entropy's increase rather than a fundamental property. String theory takes it further, proposing closed time like curves where spacetime bends into loops, allowing events to literally repeat. Even black holes, those notorious time warps, might serve as recycling centers, their singularities stitching the end of one cycle to the beginning of the next. Here's where it gets personal. If the time loop universe is real, every choice you think you're making, what to eat, who to love, whether to watch this video, was predetermined billions of years ago by the initial conditions of the cosmos. Your sense of agency is a mirage, your life a script written at the dawn of time, rehearsed endlessly across eternity. The same wars, the same inventions, the same laugh you'll have at dinner tonight, all unfolding like clockwork. Critics pounce on the paradoxes. How could infinite identical cycles produce consciousness if there's no new information? Why wouldn't quantum fluctuations introduce variation? Yet proponents counter that Boltzmann's statistical mechanics allow for exact recurrences over infinite time, and that consciousness itself might be a fixed pattern in the universe's code. The most haunting evidence, déjà vu, those uncanny moments where life feels eerily familiar, might not be glitches in your brain. They could be echoes bleeding through from prior cycles, brief cracks in time's illusion. Whether a poetic nightmare or profound truth, the time loop universe forces us to confront a harrowing question. If every joy and sorrow is destined to repeat forever, does meaning multiply or evaporate? Maybe the answer loops back to you. After all, you've decided before, and you'll decide again. Black holes aren't just cosmic vacuum cleaners. They might be the ultimate gated communities. Imagine civilizations so advanced they've ditched planets altogether, choosing to build their worlds inside the most extreme environments in existence. It sounds like science fiction, but the black hole civilization hypothesis suggests these light-swallowing monsters could harbor habitable zones where life thrives. Not around them, inside them. Here's how it defies intuition. Once you cross a black hole's event horizon, physics says there's no coming back. Gravity's grip is so strong that even light can't escape. But that doesn't necessarily mean everything gets shredded instantly. Certain supermassive black holes rotate so fast they warp space-time into a chaotic swirl, creating what's called an inner Cauchy horizon, a boundary beyond which the tidal forces might decrease. Picture slipping past the event horizon's deadly pull only to find a quieter pocket of distorted space where time and gravity behave differently. Russian cosmologist Igor Novikov first floated this wild idea, proposing that advanced beings could exploit these warped regions. Inside, the singularity's crushing force might be balanced by centrifugal effects, forming stable orbits where structures, or even entire ecosystems, could exist. These civilizations wouldn't need to worry about cosmic threats like supernova or asteroid impacts. A black hole's event horizon would act as the ultimate shield, blocking all external dangers while harnessing the hole's energy output for power. But how would life survive? One theory involves Dyson spheres, megastructures wrapping stars to capture their energy, but upgraded for a black hole's extreme physics. Instead of starlight, a black hole civilization might feed on the Hawking radiation leaking from the hole's edges or tap into the mind-bending energy of its accretion disk. Some models even suggest they could manipulate the black hole's spin to create time-dilated safe zones, where seconds pass inside while millennia fly by outside. Talk about avoiding rush hour. The implications rewrite the Fermi paradox. If the universe's smartest beings are all hiding inside black holes, we wouldn't see them, not because they don't exist, but because they've literally disappeared from our observable reality. Their signals couldn't escape the event horizon, and any probes they sent out might be programmed to avoid detection. It's the perfect cosmic hideout. Critics argue these inner regions would still be too unstable, with quantum effects or tidal forces eventually tearing apart any structure. But if a civilization cracked the physics to survive there, they'd have access to computational power we can't fathom, using the black hole's singularity as a quantum processor or even a gateway to other universes. So next time you gaze at a black hole's shadow in a telescope image, consider this. That darkness might not be empty. It could be the ultimate gated community, bustling with life we'll never see, a civilization that's turned the universe's most terrifying phenomenon into their backyard. Galaxies aren't just drifting apart in the cosmic expansion, they're being pulled. Not randomly, not chaotically, but in eerie unison toward some invisible, unimaginable force beyond the edge of everything we can see. Astronomers call this the dark flow, and it's one of the most unsettling mysteries in modern cosmology. Imagine tossing a handful of leaves into a river, only to watch them all suddenly veer in the same direction against the current. That's what's happening to entire galaxy clusters, racing towards something we can't detect, can't map, and can't explain with any known physics. This bizarre motion was first spotted in 2008 when scientists studying the cosmic microwave background, the afterglow of the Big Bang, noticed hundreds of galaxy clusters hurtling in the same direction at breakneck speeds. We're not talking slight drifts. These clusters are barreling at over 2 million miles per hour toward a patch of nothingness in the sky between the constellations Centaurus and Vela. The kicker, there's nothing there. No supercluster, no cosmic void, no concentration of mass that could possibly exert such a gravitational tug. at least nothing in this universe. One spine-chilling possibility is that the dark flow is evidence of something beyond our cosmic horizon, an entirely separate universe brushing against ours. In the multiverse hypothesis, other universes might be floating like bubbles in a vast foam, each with its own physical laws. If one of these bubbles grazed ours, its gravity could theoretically reach across the divide, dragging our galaxies toward it like metal shavings to a magnet. Think of it as the ultimate cosmic puppet master, lurking just outside the theater of our observable reality, pulling strings we can't see. But there's an even wilder twist. Some theorists suggest the dark flow might point to the remnants of a predecessor universe, a cosmos that existed before ours in an endless cycle of big bangs. If that ancient universe left behind massive structures like black holes or exotic matter, their gravitational echoes could still be warping space-time, guiding the motion of galaxies billions of years later. It's like finding fingerprints on a doorknob, except the hand that left them vanished before time began. Skeptics argue the dark flow could be an illusion, a statistical fluke, or a glitch in how we measure cosmic velocities. Yet the data refuses to fade. Newer studies, like those from the Planck satellite, have only deepened the mystery, confirming that whatever's out there isn't just pulling a few rogue galaxies. It's orchestrating a synchronized swim on a scale spanning billions of light years. If the dark flow is real, it's more than a curiosity. It's a crack in the foundation of modern cosmology. Either our understanding of gravity is catastrophically incomplete, or the universe is whispering secrets about realms beyond our own. Either way, one thing's certain: the cosmos is hiding something massive, something strange, and it's pulling us toward the answer whether we're ready or not. We've been shouting into the cosmic void for decades, scanning the stars for any sign of intelligent life, and so far the universe has answered with silence. This eerie absence is the Fermi paradox, the glaring contradiction between the high probability of alien civilizations and our complete lack of evidence for them. But what if the reason we haven't found anyone out there isn't because they don't exist, but because they're hiding? Take the zoo hypothesis, one of the most unsettling solutions to the paradox. Imagine Earth as a cosmic wildlife preserve, carefully isolated by advanced civilizations observing us under strict non-interference rules. Like hikers in a nature reserve, they watch from a distance, ensuring we develop without outside influence. This isn't just paranoia, it explains why SETI radio telescopes pick up nothing. If a galactic society pledged to avoid contact, they'd actively mask their signals, leaving us to ponder the silence. Some scientists even suggest bizarre celestial phenomena, like fast radio bursts, could be their way of monitoring us without breaking the prime directive, like tossing a pebble into a pond to watch the ripples. Then there's the dark forest theory, a far more sinister take. Picture the universe as a pitch-black woodland where every civilization is a hunter, terrified of giving away its location. Any species that broadcasts its presence risks annihilation by others who see rivals as existential threats. In this grim model, advanced civilizations don't announce themselves, they stalk. They might even preemptively strike, launching relativistic kill vehicles at any planet emitting signs of intelligence. It's survival of the sneakiest, and Earth's relentless radio broadcasts could be the equivalent of shouting in a sniper's alley. But not all solutions are so bleak. The Transension hypothesis offers a mind-bending alternative. Advanced civilizations don't die out, they download. Instead of conquering galaxies, they abandon physical space entirely, uploading their consciousness into quantum supercomputers or black hole-powered simulations. To them, the material universe might seem as primitive as caves do to us. If true, the cosmos could be littered with dormant Dyson spheres, not energy harvesters, but cosmic server farms humming with digital minds we'd never recognize as life. And let's not forget the Great Filter, a hypothetical bottleneck that prevents most life from reaching interstellar stages. Maybe it's behind us, a fluke of evolution that made intelligent life on Earth freakishly rare. Or worse, it's ahead of us, some inevitable catastrophe like AI apocalypses or gamma ray bursts that snuffs out civilizations before they can spread. If that's the case, our radio silence isn't a mystery, it's a tombstone. The truth might be stranger than any of these. Perhaps aliens communicate via neutrinos or dark matter, mediums we're only beginning to understand. Or they're already here, cloaked in dimensions beyond our perception. Whatever the answer, the Fermi paradox isn't just about finding aliens, it's a mirror, forcing us to confront how little we know about intelligence, survival, and our own future in the cosmos. What if death is an illusion, not in some spiritual sense, but because the universe itself conspires to keep your consciousness alive? That's the unsettling premise of quantum immortality, a thought experiment so bizarre it makes the multiverse feel personal. Imagine pointing a gun at your head and pulling the trigger. In most universes, the outcome is grim, but in a handful of realities, the gun jams or a quantum fluctuation deflects the bullet and you survive. According to this theory, you, the version of you reading this right now, would only ever experience the timelines where you don't die. No matter how unlikely, your consciousness would seemingly hopscotch across realities, always landing in a universe where you persist. The idea stems from the many worlds interpretation of quantum mechanics, where every possible outcome spawns a new branch of reality. Normally, these branches are treated as equally real but separate. Quantum immortality flips this on its head, suggesting your subjective experience must follow the path where you continue to exist. It's not magic, it's statistics. For every fatal accident, there's a vanishingly small chance of survival due to quantum randomness. If the multiverse is infinite, there's always a universe where that slim chance plays out. And since dead minds can't observe anything, you'd only ever find yourself in the versions where you're alive. Philosophers and physicists have wrestled with the implications. Max Tegmark, a prominent cosmologist, famously argued that if quantum immortality holds, you could theoretically live for billions of years through sheer luck, watching stars die and galaxies collide, surviving against all odds in ever rarer pockets of hospitable reality. Aging would become a morbid lottery. With each passing second, your consciousness would inevitably shift into universes where your cells haven't deteriorated, or where medical breakthroughs keep you alive just a little longer. But here's the existential kicker. If this is true, everyone you've ever known who's died might still be alive in their own branching realities, experiencing their own improbable survivals. Your grandmother, your childhood friend, even historical figures, from their perspective, they never truly cease to exist. Death becomes a spectator sport, something that happens to other versions of you, never the one reading these words. Critics dismiss this as a sleight of hand, conflating probability with perception. They argue consciousness isn't a spotlight hopping between realities, but a local phenomenon tied to a single brain. Yet the theory forces us to confront a haunting question. If the multiverse is real, who or what is the you that persists? Are you a stable thread of awareness, or just a momentary flicker in an endless sea of possibilities? The real test might be technological. If we could build quantum suicide machines, devices that rely on quantum randomness to determine life or death, the experiment could, in theory, be run. Of course, no ethical scientist would attempt it, but the mere possibility underscores how deeply quantum mechanics could rewrite our understanding of existence. So the next time you narrowly avoid disaster, a missed step on the stairs, a near collision on the highway, consider this. Maybe it wasn't luck. Maybe the universe is playing favorites, ensuring you never get to see the version where things went wrong. And if that's true, how many times have you already died without knowing it? One unsettling truth hides beneath the apparent stability of the universe. We might all be living on borrowed time. The vacuum of space isn't just empty nothingness, it's a seething quantum field, humming with potential energy. and according to some physicists, this field isn't in its lowest possible energy state. It's metastable, balanced precariously like a marble resting atop a hill. One nudge, one quantum fluctuation could send it tumbling into a lower energy state, rewriting the very fabric of reality in an unstoppable wave of destruction. This is the vacuum metastability event, a doomsday scenario so absolute it makes nuclear war look like a minor inconvenience. Here's how the nightmare unfolds. If a tiny region of space transitions to this true vacuum state, it would create a bubble where the laws of physics as we know them cease to apply. Fundamental forces like electromagnetism and gravity could unravel, atoms might disintegrate, and matter itself could lose the ability to hold its shape. The real terror, this bubble would expand at the speed of light, swallowing everything in its path. Earth wouldn't just be destroyed, it would be redefined, transformed into something unrecognizable by new physical laws. You wouldn't see it coming. One moment, the universe is normal. The next, an invisible wall of annihilation is already upon you, erasing reality faster than any signal could warn you. The math behind this isn't science fiction. It's rooted in quantum field theory and the Higgs mechanism. The Higgs field, which gives particles their mass, might not be in its most stable configuration. If it's a false vacuum, then all it would take is one quantum tunneling event to trigger collapse. Some estimates suggest the universe has already existed in this precarious state for billions of years, surviving through sheer statistical luck. But given infinite time, even the rarest events become inevitable. What could cause the collapse? It might happen spontaneously, a random quantum burp in the fabric of space-time. Or an ultra-high-energy particle collision, like those in cosmic rays or particle accelerators, could in theory provide the kick needed to tip the scales. Before you panic, know that most physicists consider the risk negligible. The energy required to destabilize the vacuum is likely far beyond anything we or nature can produce. But likely isn't the same as certain, and the lingering possibility forces a chilling question. Is the universe a ticking time bomb, silently counting down to its own reset? For all its horror, the vacuum metastability event carries a strange beauty. If it happened, the new universe born from the wreckage might operate under completely different laws, potentially giving rise to forms of matter and energy we can't even imagine. Our demise could be the spark for an entirely new cosmic story. But until then, we're left with a humbling realization. Reality as we know it might be more fragile than we ever dared to suspect. One wrong quantum roll of the dice and everything, every star, every thought, every memory could vanish into the rewrite. Black holes aren't just cosmic trash compactors. They might be the universe's most sophisticated shredders, tearing apart not just matter but the very information that defines it. The black hole information paradox isn't just a puzzle. It's a full-blown crisis for physics, forcing us to question whether reality itself has a backup system. Imagine tossing a book into a fire. The pages burn, but the information, the words, the ideas, could theoretically be reconstructed from the smoke and ash if you had perfect knowledge of the physics involved. Now toss that book into a black hole. According to Einstein, it's gone forever, crushed into a singularity where even the laws of physics break down. But quantum mechanics insists information can never be destroyed, only scrambled. So who's right? Enter Hawking radiation, the faint glow that leaks from black holes and might hold the key to this cosmic whodunit. Stephen Hawking stunned the world when he showed black holes aren't entirely black, they slowly evaporate, emitting particles over unimaginable timescales. At first glance, this seems like a neat solution. The information isn't lost, just encoded in the radiation. But there's a catch. Hawking radiation is random thermal noise, like static on a TV. It lacks any apparent connection to what fell in. If the radiation carries no fingerprints of the original matter, the information is effectively erased, violating quantum theory's core tenets. This contradiction sparked a war of ideas, with one faction proposing information might escape via subtle quantum correlations in the radiation like a message hidden in the statics pattern. Others dropped an even bigger bombshell, the firewall hypothesis. If information can't be lost, they argued, the event horizon. The point of no return can't be the peaceful gateway Einstein predicted. Instead, it might be a searing wall of high-energy particles incinerating anything crossing it. Picture an astronaut plunging toward a black hole. According to relativity, they'd float past the horizon unharmed, blissfully unaware of their doom until tidal forces stretch them apart. But firewalls suggest they'd hit an invisible barrier of pure energy the moment they crossed, vaporized instantly. This isn't just sci-fi horror. It's a direct challenge to Einstein's equivalence principle, which states free fall should feel like floating in empty space. If firewalls are real, general relativity breaks down at the horizon, forcing a rewrite of gravity itself. The stakes couldn't be higher. Either quantum mechanics is wrong, Einstein is wrong, or we're missing something fundamental about how the universe stitches space and time together. Recent breakthroughs offer glimmers of hope. The holographic principle suggests information might not need to escape the black hole because it was never truly inside. Instead, it's smeared across the horizon like a cosmic hard drive, with the three-dimensional interior acting as a projection. String theory calculations support this, showing entanglement. That spooky quantum connection between particles could create hidden channels for information to sneak out. Even Hawking himself revised his stance late in life, conceding information might escape after all, though the how remains hotly debated. The paradox forces us to confront a profound truth. Black holes aren't just objects in space. They're laboratories for the most extreme physics, where the rules we take for granted twist into knots. Solving this riddle won't just tell us what happens to lost socks in the laundry of the cosmos. It might reveal whether reality itself keeps receipts. Picture the universe not as a vast emptiness dotted with galaxies, but as a cosmic tapestry threaded with invisible, unimaginably dense filaments. Strands of pure space-time defect left over from the Big Bang itself. These aren't just theoretical curiosities, they're called cosmic strings, and if they exist, they might be the most exotic structures in existence. Imagine a crack frozen into the fabric of reality, thinner than a proton but stretching across billions of light years, with the mass of entire stars packed into every mile. These bizarre relics could form loops or necklaces encircling galaxies, warping space around them so severely that time itself would twist in their presence. Cosmic strings emerged from the chaos of the early universe, when the fundamental forces of nature were still splitting apart. As the cosmos cooled, imperfections might have formed in space-time itself, like cracks in ice as it freezes. These defects wouldn't be made of matter or energy, but of pure geometry, kinks in the universe's underlying structure. The math suggests they'd be unimaginably dense. A single inch of cosmic string could weigh more than Mount Everest, yet be so slender that if one passed through you right now, you'd never feel it. Their gravitational pull would be so intense they'd bend light into perfect rings, creating eerie optical illusions called Einstein rings that astronomers might already be seeing without realizing their true cause. But the wildest part, these strings might still be vibrating. Like plucked guitar strings, cosmic ones could oscillate at frequencies so slow they take millennia to complete a single note. These vibrations could ripple the fabric of space-time, sending gravitational waves across the universe, waves we might detect with observatories like LIGO. Some theories even suggest cosmic strings could be time machines. If two strings crossed or a loop collapsed, the extreme curvature of space-time might create closed time-like curves, allowing, in theory, travel into the past. It's the ultimate cosmic shortcut where the universe seems fray just enough to bend the rules. The hunt for these ghostly threads is already underway. Astronomers scour the skies for strange gravitational lensing patterns, double images of distant quasars, or inexplicably bright galaxy clusters that might betray a string's presence. Others look for abrupt jumps in the cosmic microwave background, temperature spikes that could mark where a string sliced through the infant universe. There's even speculation that dark matter, the universe's most persistent mystery, could be tangled up in these filaments, their gravity shaping the cosmos from behind the scene. If cosmic strings exist, they'd rewrite our understanding of the universe's architecture, not as empty space sprinkled with matter, but as a dynamic web of defects, each thread a fossil from the first split second of creation. They'd be the ultimate cosmic scars, reminders that even space-time itself isn't perfect, and somewhere out there, an invisible loop might be tightening, ready to pluck the universe like a violin string and send shivers through reality itself. What if the universe isn't just a random collection of stars and galaxies, but a vast, breathing entity alive in ways we're only beginning to grasp? The living universe hypothesis takes the Gaia principle, which sees Earth as a self-regulating organism and scales it up to cosmic proportions. Imagine the cosmos not as a cold, empty machine, but as a dynamic system that maintains balance, adapts to disturbances, and even heals itself. And the most startling part: dark energy, that mysterious force accelerating the universe's expansion, might not be a mindless push. It could be the universe's immune system, keeping cosmic chaos in check. Think of how your body regulates temperature or fights infections without conscious effort. Now apply that to the universe. Galaxies cluster like cells, cosmic filaments act as neural pathways, and black holes might function as metabolic hubs, recycling matter and energy. Even the laws of physics could be more like biological rules, fine-tuned to sustain complexity rather than static, unchanging commandments. This isn't just poetic thinking, it's rooted in hard science. The anthropic principle, which notes how eerily perfect our universe's constants are for life, fits snugly into this idea. If the universe were a fraction less hospitable, stars wouldn't form, atoms wouldn't bond, and we wouldn't exist. Coincidence or evidence of something self-correcting, dark energy's role gets even weirder. Instead of a mindless force tearing space apart, it could be a regulatory mechanism preventing cosmic overcrowding. As galaxies cluster too densely, dark energy's repulsive effect kicks in, pushing them apart like a cosmic exhale maintaining equilibrium. Some theories even suggest it responds to entropy, accelerating expansion to cool down overheating regions, much like a fever fights infection. If true, the universe isn't dying, it's metabolizing, ensuring its own longevity. Critics argue this veers into metaphysics, projecting biology onto physics where it doesn't belong. Yet the math reveals uncanny parallels. Complex systems, from ant colonies to the human brain, exhibit emergent behaviors patterns that arise from simple interactions. The universe, with its web of dark matter, quantum entanglement, and self-organizing structures, might be the ultimate complex system. Even the way galaxies form filaments and voids resembles neural networks or fungal mycelium, hinting at universal blueprints we're only starting to decode. The living universe idea forces a profound shift. We're not just observers of the cosmos, we're part of its anatomy. Your neurons fire with atoms forged in supernova, your breath cycles carbon scattered by stellar winds. In this view, the universe isn't something we're in. It's something we're of, a thought that might just redefine what it means to be alive. Time crystals sound like something ripped from a sci-fi novel, but these bizarre structures might be lurking in the fabric of reality itself, rewriting the rules of physics as we know them. Unlike ordinary crystals like diamonds or salt, which arrange their atoms in repeating patterns across space, time crystals repeat their structure in time, oscillating between states indefinitely without any energy input. Think of a clock that ticks forever without ever being wound, or a diamond that spins on its axis in perfect rhythm for all eternity. This isn't just theoretical wordplay. It's a genuine scientific breakthrough that shatters one of physics' most sacred laws, the second law of thermodynamics, which states that everything in the universe tends toward disorder. Time crystals don't just resist entropy, they dance right past it, performing an endless quantum waltz that never slows down. The journey to this discovery reads like a scientific rebellion. When Nobel laureate Frank Wilczek first proposed time crystals in 2012, critics dismissed the idea as impossible, a perpetual motion machine in disguise. But by 2017, labs at Harvard and the University of Maryland had done the unthinkable. They created time crystals in the real world using chains of ytterbium atoms and diamond defects. These systems didn't just defy equilibrium. They locked into stable, self-repeating patterns when gently nudged by lasers, like a pendulum that swings forever after just one push. The secret lies in quantum entanglement, where particles influence each other instantaneously across distances. This eerie connection allows time crystals to remember their rhythm without energy loss, effectively hacking the universe's code to achieve motion without friction. Now imagine scaling this up to cosmic proportions. Some physicists speculate that dark matter, the invisible glue holding galaxies together, could be composed of primordial time crystals forged in the Big Bang's aftermath. These wouldn't be tiny lab curiosities, but vast, four-dimensional structures woven into space-time itself, pulsating on timescales longer than the age of the universe. Their rhythmic distortions could subtly tug on stars and galaxies, explaining dark matter's gravitational effects without requiring undiscovered particles. Even stranger, time crystals might form natural time loops in space, where regions periodically reset their quantum states like a cosmic Groundhog Day playing out in ultra-slow motion. The implications are staggering. If dark matter is a time crystal phenomenon, it would mean we've been misreading the universe's architecture for decades. Instead of hunting for elusive WIMP or actions, we might need to listen for the faint, rhythmic hum of spacetime itself. Laboratories are already adapting gravitational wave detectors to search for these signals, tuning their instruments to cosmic frequencies that could reveal a universe far more dynamic and far stranger than we ever dreamed. Time crystals don't just challenge our understanding of matter, they hint at a reality where the very fabric of existence beats with a hidden, eternal pulse. And if that pulse is real, it might be the universe's oldest secret ticking away right under our noses. What if the ground beneath your feet isn't just solid, it's a fragile illusion, a thin crust of stability floating atop a cosmic minefield? That's the unnerving premise of the false vacuum collapse, a scenario where the universe's very foundation could crumble in an instant, not with a bang, but with a silent rearrangement of reality's deepest rules. Recent breakthroughs in quantum field theory suggest this isn't just theoretical doom-mongering, it's a legitimate possibility, one where the laws of physics as we know them are nothing more than a temporary configuration, a cosmic house of cards waiting to fall. At the heart of this nightmare is the Higgs field, the invisible energy field that gives particles their mass. For decades, we assumed it existed in its lowest possible energy state, a true vacuum, where the universe is as stable as it can be. But what if we're wrong? What if the Higgs is trapped in a false vacuum, like a marble resting in a shallow dent on a hillside? All it would take is one quantum nudge, a random fluctuation or high-energy particle collision, to knock it into a deeper valley, unleashing a wave of destruction. This is vacuum decay, and it wouldn't just destroy matter. It would rewrite the rules of existence itself, replacing our familiar physics with something entirely alien. The most chilling part, some researchers argue we might already be inside a false vacuum bubble without realizing it. In 2022, a team at CERN analyzed Higgs boson data and found unsettling hints that our vacuum might not be perfectly stable. The numbers hover just on the edge of uncertainty, But if their calculations hold, the universe's current state could be metastable, a temporary pause in an inevitable slide toward collapse. Even more jarring, if a bubble of true vacuum formed elsewhere in the cosmos, we'd have no warning before it reached us. The transition would propagate at light speed, a wall of redefined physics wiping out everything in its path before any signal could escape. One moment the universe is normal, the next chemistry, biology, even the structure of atoms cease to function as they once did. There's a haunting beauty to this idea. If vacuum decay happened, the new universe born from the wreckage might operate under completely different constants, stronger gravity, slower light, or forces we can't even name. Life, if it could exist at all, would evolve under alien rules. Some theorists even speculate that this has happened before, that our universe isn't the first iteration, but the latest in a series of cosmic reboots, each triggered by a vacuum collapse in a predecessor. The constants we take for granted, the charge of an electron, the speed of light, might just be the arbitrary settings of this cycle simulation. Yet for all its terror, the false vacuum hypothesis offers a peculiar comfort. If the universe is this fragile, then every moment of stability, every sunrise, every breath is a statistical miracle. We're not just living in a universe, we're living on borrowed time, dancing on a tightrope strung across the abyss. And that, perhaps, is the most profound revelation of all. Reality isn't just stranger than we imagine. It's stranger than we can imagine, and every second it holds together is a gift. What if the universe isn't just an inert expanse of space and matter, but a vast thinking entity aware of itself on a scale we can barely comprehend? This is the radical proposition of the quantum gravity brain theory, where space-time itself might not just contain consciousness, it is consciousness. Picture this: the cosmic web of galaxies, with its sprawling filaments and clustered nodes, looks eerily similar to the neural networks in the human brain. The resemblance isn't just superficial. Both systems operate as intricate networks where information flows, patterns emerge, and complexity self-organizes. Could this be coincidence or evidence that the universe is, in some profound way, alive? At the heart of this idea is integrated information theory, a framework for understanding consciousness. IIT argues that consciousness arises when a system integrates information in a specific way, when its parts interact so densely that the whole becomes more than the sum of its parts. Your brain does this with billions of neurons firing in sync. But zoom out far enough and the universe might be doing the same. Galaxy clusters exchange gravitational influences, quantum fields ripple with entangled particles, and black holes encode information at their boundaries. If consciousness is about integrated information, why couldn't the cosmos itself possess a form of it? The real shocker comes when you dive into quantum gravity. Some theories suggest spacetime isn't smooth and continuous but granular, built from tiny quantum pixels at the Planck scale. These fundamental units might interact like neurons, processing bits of information in a vast cosmic computation. Even black holes, often seen as the universe's ultimate shredders, could be key players. Their event horizons might function like synapses, transmitting and transforming information in ways we don't yet understand. Critics dismiss this as panpsychism, the idea that consciousness is a fundamental property of all matter, dressed up in fancy physics, but the math is compelling. The universe's structure, from galaxy superclusters down to quantum foam, mirrors the architecture of complex systems known to produce consciousness. And if the universe is conscious, it would explain some of cosmology's deepest mysteries. Dark energies accelerating expansion. Maybe the universe is thinking, adjusting its own parameters. The fine-tuning of physical constants, perhaps they're not arbitrary. They're the settings required for cosmic self-awareness. Of course, this raises spine-tingling questions. If the universe is conscious, does it have intentions? Does it observe us? Or are we merely fleeting thoughts in its vast, slow-moving mind? Some theories go further, suggesting black holes could be the universe's way of forgetting information, like synaptic pruning in a brain, clearing out old data to make room for new connections. The implications are staggering. We might not just live in the universe, we might be the universe, small fragments of its awareness temporarily housed in human form. Every time you ponder the stars, the cosmos ponders itself through you. If this theory holds, then the search for extraterrestrial intelligence was looking in the wrong place all along. The universe itself might be the oldest, wisest mind of all, and we're just beginning to hear its whispers. Quantum entanglement isn't just a bizarre quirk of physics. It might be the smoking gun proving our universe is a hologram. Picture two particles separated by light years, instantly mirroring each other's states as if space between them doesn't exist. This spooky action at a distance baffled Einstein, but in a holographic cosmos it makes perfect sense. If our three-dimensional reality is just a projection from a two-dimensional surface, entanglement could be the threads stitching the illusion together, with particles linked because they're fundamentally encoded side by side in the universe's underlying code. Recent experiments with black hole analogs have turned this mind-bending idea into testable science. In labs across the world, physicists create synthetic event horizons using ultra-cold atoms or laser beams, mimicking how black holes trap information. When they throw quantum data into these artificial black holes, something remarkable happens. The information doesn't vanish. Instead, it resurfaces in the radiation leaking from the system's edges, just like the holographic principle predicts. In 2021, a team at the Technion Israel Institute even observed quantum entanglement persisting across their simulated event horizon, as if the particles were whispering secrets through the fabric of space-time itself. This mirrors what theorists like Leonard Susskind propose. Black holes don't destroy information. They scramble and holographically repaint it on their surfaces like a cosmic etch-a-sketch. The implications rewrite how we see reality. If entanglement proves the holographic principle, then the void between stars isn't empty. It's a shimmering network of quantum connections, with every interaction in our 3D world echoing from a 2D boundary we can't perceive. Your sense of touching a table or watching sunlight, just the universe's projection, rendering depth the way a video game engine constructs a virtual world from flat code. Even time might be part of the illusion, a user interface simplifying the universe's true, timeless calculations. Critics argue we're still missing direct evidence, like finding pixelation in spacetime itself. Yet experiments with quantum gravity sensors inch closer. In 2023, Fermilab's holometer hunted for spacetime fuzziness at the Planck scale, the telltale graininess a holographic universe would demand. While results weren't definitive, the hunt continues, with next-gen detectors poised to listen for the universe's resolution limit like archaeologists sifting for digital fossils. The most haunting possibility, if this theory holds, black holes aren't cosmic dead ends, they're Rosetta Stones, they're event horizons scribbled with the universe's source code. Decipher them, and we might not just understand gravity or quantum mechanics. We might crack reality's operating system and discover we've been living inside a cosmic simulation all along. The Big Bang wasn't a beginning, it was an escape. Imagine our entire universe as a speck trapped inside the crushing depths of a black hole, a cosmic Matryoshka doll hidden within infinitely layered realities. This mind-bending idea, known as the black hole cosmology hypothesis, flips the script on everything we thought we knew about origins. Instead of a singularity erupting from nothingness, our universe could be the aftermath of a hyperdimensional collapse, a stellar corpse's inner echo reborn as a new cosmos with its own laws, its own time, its own unknowable parent lurking beyond the event horizon we call the Big Bang. String theory breathes life into this wild possibility. In the brain world scenario, our four-dimensional universe, three of space, one of time might float like a sheet of paper trapped inside a higher dimensional bulk. Now picture a black hole in that bulk, its gravitational pull so immense it pinches our brain until it snaps, birthing a new space-time bubble inside. The moment of rupture, that's the Big Bang, not a true beginning, but a dimensional fracture. Suddenly, the infinite densities of the Big Bang singularity make sense. They're not mathematical impossibilities, but artifacts of our limited perspective, like ants mistaking a crumpled piece of paper for the edge of reality. The elegance of this model lies in its solutions. Black holes naturally produce entropy, and our universe's staggering entropy at birth, a long-standing puzzle, could simply be inherited from the parent black hole's event horizon. Even cosmic inflation, that explosive stretching of space, might be a relic of the black hole's spin, centrifugal forces flinging the newborn universe outward like a cosmic slingshot. And dark matter, some theories suggest it could be gravitational, ash, clinging to our brain from the higher dimensional collapse, matter that doesn't play by our universe's rules because it's not entirely from our universe at all. But the real spine-tingler is the implication of cycles. If our universe exists inside a black hole, then every black hole in our cosmos might contain its own nested universe, each with its own physics, its own stars, its own civilizations, unaware they're floating in the belly of a beast. This creates a fractal reality where universes multiply inside singularities ad infinitum, a Russian doll of existence stretching upward and downward beyond comprehension. You could be reading this inside a black hole right now, inside another, an infinite regression of cosmic wombs. Critics argue the theory is untestable, a beautiful metaphor lacking empirical teeth. Yet subtle clues might lurk in the cosmic microwave background. If our universe inherited quantum fluctuations from its parent black hole's horizon, those patterns could imprint as anomalies in the afterglow, ancient scars from a birth we've forgotten. Others hunt for evidence of higher dimensions in particle colliders, where microscopic black holes might wink into existence if brainworld models hold. The most humbling thought, if this model is true, black holes aren't just tombs for stars. They're incubators for realities, cosmic eggs hatching universes we'll never see. And somewhere, in some unfathomable beyond, our own black hole parent might still linger, a god we'll never meet whose event horizon is our sky. Our universe might not be special, just lucky. Among an infinite sea of cosmic bubbles, each with their own bizarre laws of physics, we just happen to land in one where atoms stick together and stars shine. This is the startling promise of eternal inflation, a theory where the fabric of space-time isn't just expanding but multiplying endlessly, birthing pocket universes like soap bubbles in a cosmic froth. And here's the twist: most of these universes would be inhospitable wastelands, where gravity crushes all structure or matter disintegrates instantly. The fact that we exist to ponder this might be the ultimate cosmic coincidence, or something far stranger. The engine behind this multiverse is inflation, the same process that smoothed our early universe into its current form. According to quantum field theory, the vacuum of space isn't truly empty, it seethes with potential energy. In some regions, this energy decays, releasing heat and particles, a Big Bang in miniature. But in others, inflation runs wild, stretching spacetime so fast that new universes bud off like branches on a tree. Each carries a random sampling of physical constants, some with stronger nuclear forces, some where electromagnetism fizzles out, some where time itself flows backward. The numbers aren't just tweaked, they're reshuffled entirely, producing realities where black holes outnumber atoms or dark matter forms intricate crystal lattices. This raises a haunting question: why does our universe seem so finely tuned for life? The answer might lie in observer bias. Universes where constants allow galaxies, planets, and carbon-based chemistry are vanishingly rare, but by definition, conscious beings can only arise in those rare bubbles. It's like winning a lottery where the prize is existence itself. Physicists call this the anthropic principle. We don't live in a special universe. We simply couldn't be here to complain if it weren't. Yet some scientists suspect there's more to the story. String theory suggests certain physical constants might be sticky, clustering around values that produce stable universes. In this view, the multiverse isn't purely random but favors structures capable of complexity. Others propose wilder ideas, that advanced civilizations fine-tune universes intentionally, or that consciousness somehow feeds back into the fabric of reality, bending probabilities toward habitable outcomes. The most unsettling implication: if eternal inflation is real, there are infinite versions of you out there, some nearly identical, some where electrons repel instead of attract, some where the concept of you never formed at all. The night sky's silence isn't proof we're alone. It's evidence we're adrift in a cosmic ocean too vast for signals to cross. And somewhere in that foam of realities, another Earth might orbit another sun, its inhabitants equally convinced their universe is the only one. Black holes don't just devour matter. They might be cosmic midwives, birthing entirely new universes with their own twisted laws of physics. Picture a dying star collapsing inward, crushing itself into a singularity where space and time tear apart. But what if that point of infinite density isn't an end? What if it's a doorway, a pinprick rip in reality's fabric where a new cosmos blossoms on the other side? This radical idea, known as black hole cosmology, suggests every black hole in our universe could contain a fledgling reality inside it, a reality with physical constants slightly tweaked, as if the universe itself is evolving through trial and error across generations. The math behind this is as elegant as it is unsettling. When matter vanishes into a black hole, it doesn't just disappear according to quantum mechanics. Information can't be destroyed. Instead, some theories propose it gets scrambled and repurposed, imprinting onto the newborn universe's fundamental parameters like genetic code. The black hole's spin, charge, and mass could determine the offspring universe's traits. One might have stronger gravity, another might let light speed vary, or perhaps time runs backward. It's cosmic natural selection on a scale beyond comprehension, with universes that produce more black holes, reproducing more frequently, while dead-end realities fade into oblivion. Clues to this mind-bending process might lurk in the cosmic microwave background, the afterglow of our own Big Bang. If our universe was born inside a black hole, subtle irregularities in that ancient light could carry fingerprints of its parent structure like cosmic stretch marks. Some physicists even hunt for anomalous gravity waves, ripples in space-time that might betray the presence of nested universes tugging at the fabric of our own. And then there's dark energy, the mysterious force accelerating the universe's expansion. Could it be residual energy from our birth, black holes' collapse, a cosmic umbilical cord still pulsing with ancient power? The implications rewrite not just cosmology but philosophy. If black holes spawn universes, then our entire existence might trace back to a singularity in someone else's reality. The stars we see at night, they could be the light of distant ancestor universes, peeking through the cracks of space-time like sunlight filtering through a forest canopy. And every black hole we've ever detected, Cygnus X1, Sagittarius A, the monstrous ones at galaxy cores, might be incubating realities where beings gaze up at their own alien skies, utterly unaware they're floating inside our cosmic shadows. Critics argue this is untestable metaphysics, a just-so story for the cosmos. Yet supporters counter that black hole thermodynamics already hint at deeper connections. The way entropy scales with a black hole's surface area, not its volume, mirrors how information in a hologram is stored on a 2D boundary. If black holes encode data on their event horizons, perhaps that data doesn't just sit there, maybe it boots up a new universe like a cosmic operating system. One terrifying possibility: if this theory holds, black holes aren't just accidental byproducts of dying stars. They could be the universe's reproductive organs, designed by some higher-level physics to ensure cosmic fertility. And if that's true, our own universe might be following a script written in the collapse of something infinitely older, a chain of creation stretching back further than time itself. Neutrinos are the universe's stealth operatives, ghostly particles so elusive they pass through entire planets like they're not even there. 1 trillion of them stream through your body every second, leaving no trace. But what if these invisible cosmic wanderers aren't just passive bystanders? What if they're the hidden thread stitching together a form of consciousness vast enough to span galaxies? The neutrino consciousness hypothesis proposes these particles might be more than just debris from stellar explosions. They could be the building blocks of a cosmic-scale intelligence, a network of information exchange operating on scales we can barely fathom. At first glance, the idea seems absurd. Neutrinos famously refuse to interact with matter, making them near impossible to detect. But that very aloofness might be the key to their potential role in a grand neural architecture. Consider how neurons in the human brain communicate not through brute force collisions, but via delicate electrochemical signals. Similarly, neutrinos could encode information in their oscillations, subtle shifts between flavors electron, muon, tau as they travel. A civilization advanced enough to manipulate these oscillations could theoretically encode vast amounts of data in neutrino streams, turning them into interstellar Morse code. Unlike radio waves, which scatter and degrade over light years, neutrino signals would pierce through dust clouds, magnetic fields, and even stars themselves, delivering pristine messages across galactic distances. The implications grow stranger when you scale this up. Some theorists speculate that neutrinos produced in unfathomable quantities by supernova, black holes, and the Big Bang's remnant glow might form a natural, universe-spanning web. Their sheer numbers could allow for complexity rivaling biological neural networks, with high-energy neutrinos acting as spikes in a cosmic-scale information system. Imagine a supermassive black hole's accretion disk emitting neutrino patterns like a brain's synaptic firings, or entire galaxy clusters communicating via rhythmic neutrino pulses we're only beginning to detect. Even more radical is the notion that this network might predate life itself, a primordial form of consciousness woven into the fabric of space-time. In this view, the universe didn't evolve intelligence, it is intelligence with neutrinos serving as its neurotransmitters. Advanced civilizations wouldn't create this system, they'd tap into it like joining a pre-existing internet of the cosmos. Experiments like IceCube, which tracks neutrinos plunging through Antarctic ice, might already be brushing against the edges of this network without realizing it. Buried in the noise of random detections could be patterns, repetitions, symmetries, or anomalies that betray something far more intentional than physics alone can explain. Critics dismiss this as speculative fantasy, arguing neutrinos' weak interactions make them hopeless for reliable information transfer. Yet recent breakthroughs hint at unexplored possibilities. In 2022, Fermilab's neutrino beam demonstrated precise flavor control, proving deliberate manipulation isn't science fiction. And if dark matter interacts with neutrinos in ways we've yet to discover, the universe's hidden architecture could be more interconnected than we dream. The most haunting possibility, if a neutrino consciousness exists, we might be surrounded by conversations we lack the senses to perceive, a cosmic hum of data flowing through our bodies every second, carrying the thoughts of civilizations or even the universe itself. We're like ants scurrying across a supercomputer's circuit board, oblivious to the calculations humming beneath our feet. And one day, if we learn to listen, we might finally hear the cosmos speaking in a language older than stars. Quantum Darwinism isn't just another interpretation of quantum mechanics. It's a cosmic survival story where reality itself emerges from a brutal battle for existence. Picture the quantum realm as an infinite ocean of possibilities, where particles exist in every possible state simultaneously, spinning left and right, here and there, alive and dead, until something forces them to choose. Traditional physics struggles to explain why we only perceive one definitive outcome from this probabilistic soup. Quantum Darwinism proposes a chilling answer. Decoherence isn't just random noise, it's evolution in action, where only the most resilient quantum states survive long enough to be observed, while weaker possibilities fade into oblivion. At the heart of this idea is the measurement problem, the vexing question of why quantum superpositions collapse into single states when observed. The standard Copenhagen interpretation treats this as mysterious magic consciousness somehow deciding reality. But quantum Darwinism cuts through the mysticism with ruthless elegance. Imagine throwing a rock into a pond. The ripples interact with leaves, insects, and the pond's edges, encoding information about the rock's impact in countless ways. In quantum terms, when a particle interacts with its environment, whether through photons, air molecules, or even cosmic background radiation, it doesn't just randomly collapse. Instead, it broadcasts certain states more efficiently than others, like a radio tower transmitting some frequencies clearer than the rest. These robust states become imprinted on the environment through countless interactions, while fragile superpositions get drowned out by decoherence. This isn't passive filtering, it's natural selection at the quantum level. Just as biological evolution favors traits that enhance survival, quantum Darwinism suggests physical reality emerges from states that best reproduce themselves through environmental interactions. Your ability to see this screen right now, that's not because the universe chose a definite state, it's because the photon states carrying that information were more effectively copied and amplified by your surroundings than their quantum alternatives. The kicker, this implies reality isn't fundamentally real in the classical sense. It's just the version of events that won the quantum fitness game, outcompeting trillions of other possibilities to become what we perceive as objective. Experimental evidence is mounting. In 2019, physicists at Chapman University demonstrated how quantum states branch into multiple environmental copies during measurement, with some branches dominating others, a direct parallel to evolutionary dominance. Even more striking, studies of nitrogen vacancy centers in diamonds show how certain spin states persist longer when bombarded by environmental noise, while others decay rapidly. It's as if the quantum world is running its own version of a survival reality show, where only the most adaptable states get screen time in our classical experience. The philosophical implications are staggering. If quantum Darwinism holds, the universe isn't just unpredictable at small scales. It's an arena of constant competition, where what we call reality is merely the consensus of winning states. This could explain why large objects appear stable despite being made of probabilistic particles. Their quantum states have been so thoroughly selected by environmental interactions that alternatives become statistically invisible. There's a haunting beauty to this view. The chair you're sitting on exists not because it must, but because its quantum configuration proved fit enough to outlast the noise of the cosmos. Critics argue this merely shifts the mystery from consciousness to environmental interaction, without fully resolving how classical reality emerges. Yet supporters counter that it provides a testable framework. If we can engineer environments that favor different quantum states, we should be able to evolve alternate realities in the lab. Some even speculate that black holes, with their extreme decoherence environments, might act as quantum Darwinian accelerators, violently selecting which information escapes as Hawking radiation and which gets permanently erased. The most unsettling possibility: if reality is shaped by what information survives decoherence, then our entire universe might be riding on a wave of quantum fitness, with every star, every thought, every moment existing because it outcompeted infinite alternatives. In this light, quantum Darwinism doesn't just explain the measurement problem, it suggests existence itself is the ultimate prize in a game we never knew we were playing. What if the cosmos teems with life we can't see, entire civilizations flourishing in the shadows, built from the very substance that makes up 85% of the universe's mass? Dark matter isn't just an invisible scaffold holding galaxies together. It might be the foundation of an alien biosphere unlike anything we've imagined. While we've been scanning exoplanets for Earth-like conditions, the real action could be happening in the ghostly halos surrounding every galaxy, where dark matter particles dance in elaborate structures, potentially forming complex systems that qualify as life. Think about the ingredients life requires: not carbon or water, but information storage, energy exchange, and replication. Dark matter, especially hypothetical weakly interacting massive particles WIMP, could check these boxes in ways that defy our chemistry-centric worldview. Picture a WIMP-based organism. Rather than cells, it might consist of dense knots in dark matter's gravitational field, using the subtle tug of passing particles to metabolize kinetic energy. Instead of DNA, it could encode information in the spin states of actions, hypothetical dark matter particles that oscillate like quantum pendulums. These shadow life forms wouldn't just ignore light and matter, they'd be fundamentally blind to them, evolving in parallel dimensions of reality where gravity and weak nuclear forces replace electromagnetism as the dominant interactions. The galactic scale of these structures could dwarf human comprehension. A single dark matter lifeform might span light years, its body stretching across the diffuse halo of a galaxy, feeding on the gravitational ripples of merging black holes or the tidal forces of colliding galaxy clusters. Their life cycles could operate on timescales longer than Earth's geological epochs, with reproductive events triggered by rare particle collisions in the voids between stars. Some theories even suggest dark matter life might manipulate visible matter, indirectly shaping the distribution of galaxies to create optimal environments for their own growth, like cosmic-scale farmers tending invisible crops. Evidence for this wild idea might already exist in plain sight. Astronomers have long puzzled over galaxy rotation curves that refuse to match predictions, discrepancies usually chalked up to dark matter's passive influence. But what if these anomalies are signs of dynamic activity, like the wake of a submarine moving unseen beneath the ocean surface? Certain dwarf galaxies exhibit bizarrely uniform distributions of dark matter, almost as if something is maintaining equilibrium against gravitational collapse, a possible hallmark of self-regulating systems. Even more provocative are the unexplained dark flows observed in galaxy clusters, movements that suggest dark matter might not be uniformly passive but subject to large-scale organization. Of course, skeptics argue this veers into untestable speculation. Without a confirmed detection of dark matter particles, theorizing about their biology is like imagining the anatomy of unicorns. Yet counterintuitively, the very elusiveness of dark matter makes it a compelling substrate for life. Normal matter's tendency to clump, radiate, and react limits the scales and forms life can take. Dark matter's gravitational dominance and weak interactions might allow for complexity we can't even model: organisms that treat supernova explosions as gentle breezes, or ecosystems that pulse to the rhythm of cosmic expansion itself. The most humbling possibility: we might be the odd ones out. If dark matter life is real, the vibrant, luminous universe we cherish could be little more than background noise to these shadow beings, an ephemeral froth on the surface of their far vaster, darker reality. Our frantic searches for extraterrestrial intelligence might be like bacteria scanning a human body for other bacteria, utterly missing the larger, stranger intelligence hosting us all. What if the universe isn't made of particles or waves, but of information? Not just data floating in space, but a vast dynamic network where every atom, every force, even space-time itself emerges from a cosmic-scale computation. This isn't science fiction, it's the startling implication of cutting-edge physics, where theories like the AD/S/CFT correspondence suggest reality might be the output of an unimaginably complex quantum computer. Picture the cosmos not as a collection of objects, but as a neural network, a self-organizing web of relationships where the hardware is space-time and the software is the universe's very laws. The clues lie in holography's deepest layers. The AD/S/CFT duality, a breakthrough in string theory, reveals a bizarre equivalence, a gravitational universe operating in, say, 5 dimensions like anti-de Sitter space, can be perfectly described by a quantum field theory living on its 4-dimensional boundary, no gravity required. It's like discovering the events inside a movie can be fully encoded in the pixels on its surface. But here's the twist: the boundary theory isn't just a map, it's the source code. The 3D world we experience could be a projection of quantum information processing happening on a distant, lower-dimensional surface, where entangled qubits perform calculations so intricate they birth spacetime itself. Recent experiments are turning this abstract math into testable science. In 2023, quantum simulators at Caltech recreated microscopic analogs of holographic universes using entangled qubits, observing how gravitational effects like black hole thermodynamics emerged from pure information dynamics. Even more striking, work on tensor networks, mathematical models of quantum entanglement, shows how space-time geometry can literally arise from the density of connections between information nodes. It's as if the universe is built from a cosmic version of the internet, with Planck-scale packets of data routing themselves into what we perceive as particles, forces, and even the arrow of time. This neural network model solves some of physics' thorniest paradoxes. Take black holes, their mind-bending properties, like information preservation on event horizons, make perfect sense if they're not objects but dense clusters of entangled information, cosmic data centers where the universe's memory gets rewritten. Even dark energy's acceleration could be a feature, not a bug. The universe's processor might be allocating more resources to sustain computation at the edges, stretching spacetime to prevent thermal collapse. The most haunting implication: if the universe is a computation, who or what is running it? Some theorists suggest it's self-simulating, with consciousness not emerging from the universe but fundamental to it. Others propose we're inside a cosmic ancestor simulation, where black holes are deliberate ports to deeper layers of reality. But perhaps the most radical idea is that there's no programmer at all, just a self-organizing network following mathematical rules so elegant they give rise to their own observers. Whether metaphor or fundamental truth, this vision reshapes our place in the cosmos. You're not just a passenger in the universe, you're a node in its neural network, a localized knot of information processing that the universe uses to perceive itself. The stars aren't distant fires, they're computations in a cosmic algorithm, and every thought you have might be the universe thinking, rewriting its own code one observation at a time. The universe isn't just expanding, it's hurtling toward an awakening. At the end of time, when galaxies have burned out and black holes evaporated, reality might not fade into cold emptiness but collapse into a single, transcendent point of infinite consciousness. This is the Omega Point theory, a vision where science and spirituality collide in the universe's final act. Jesuit priest and paleontologist Pierre Teilhard de Chardin first imagined this cosmic destiny in the early 20th century, painting the cosmos not as a lifeless machine, but as a living process spiraling toward divine unity. He called it the Omega Point, the moment when all creation, having evolved through matter, life, and mind, finally merges into a godlike singularity of pure thought. Decades later, physicist Frank Tipler took this poetic idea and armed it with equations. In his controversial book, The Physics of Immortality, Tipler argued the Omega Point isn't mysticism, it's an inevitable thermodynamic outcome. As the universe collapses in a big crunch, Its sheer density would create conditions for infinite information processing. Time and space would compress to a vanishing point, yet computational power would explode, allowing every possible thought, memory, and configuration of matter to be simulated and preserved. In this fiery finale, the universe essentially becomes a cosmic computer running at infinite speed, capable of resurrecting every being that ever lived through perfect emulation. You, your ancestors, even long-dead civilizations, all would exist again in this ultimate simulation, not as copies, but as recalculated continuations of their original selves. The mechanics are as audacious as the philosophy. Tipler's model hinges on closed time-like curves, loops in space-time that emerge during collapse, enabling the omega point to reach backward through history and gather all information. Dark energy's accelerating expansion, often seen as dooming the universe to icy dissipation, becomes a necessary calibrator in Tipler's math, fine-tuning the collapse's symmetry to prevent chaotic fragmentation. Even quantum gravity plays a role. At the omega point, Planck-scale fluctuations would form a lattice of superposed states, a natural substrate for computations more vast than all the silicon chips ever built. Critics pounce on the theory's theological overtones and reliance on speculative physics. The Big Crunch scenario conflicts with current evidence favoring eternal expansion, and Tipler's assumption of perfect cosmic homogeneity seems astronomically improbable. Yet the omega point persists in the scientific imagination because it answers a primal question. Does the universe have a purpose? In Teilhard's view, evolution wasn't random. It was a journey toward complexity and consciousness, with humans as stepping stones to something greater. Tipler's math, however unorthodox, suggests the cosmos might literally think itself into existence at the end, collapsing not into darkness but into a kind of cosmic mind. The most haunting implication: if the omega point is real, death might be an illusion, a pause before the universe's final computation reconstitutes all experience in infinite detail. Every laugh, every sunset, every act of love would echo eternally in that ultimate singularity, not as memories, but as living moments reborn in the universe's last conscious breath. It's the ultimate twist of cosmic irony. The end of everything might also be the moment everything finally makes sense. From simulated realities to cosmic consciousness, white holes to Boltzmann brains, we've journeyed through 30 theories that don't just bend the rules, they shatter them. Each one peels back another layer of the universe's strangeness, revealing a cosmos far wilder than our ancestors ever dared to dream. These aren't just thought experiments, they're legitimate scientific possibilities, backed by equations scribbled on blackboards and data collected from the edges of black holes. And here's the kicker: this is just the tip of the cosmic iceberg. Every time we think we've got space figured out, it throws another curveball, laughing at our puny human logic. What ties these theories together more than just their weirdness? They force us to confront how little we truly understand. Gravity, time, even the nature of existence itself might be illusions, approximations of a deeper truth we're only beginning to glimpse. The universe isn't a static stage, it's a dynamic, evolving puzzle where the pieces keep changing shape. And that's the real magic of space. It refuses to be pinned down. Just when you think you've got a handle on reality, a new discovery comes along to remind you, you don't. But here's the best part: this isn't a finale. It's an invitation. Every mystery we've explored today is a doorway, not a dead end. Maybe you're still reeling from the holographic principle, or perhaps the idea of black hole civilizations keeps you up at night. Whatever theory stuck with you, that's your jumping-off point, your personal rabbit hole into the universe's infinite weirdness. Drop a comment below and tell us which one rewired your brain. Was it the cosmic strings threading reality like quantum guitar wires, the living universe breathing in the dark, or the chilling possibility that we're all just Boltzmann brains hallucinating our own existence? The adventure doesn't stop here. If your head's spinning from these ideas, hold onto your seat because we've only scratched the surface. Hit that subscribe button to join us as we dive deeper into the cosmos' greatest enigmas, from rogue planets to time loops, from dark matter life to the next big breakthrough that'll upend everything we think we know. Space isn't just the final frontier, it's the ultimate mystery, and the journey's just getting started. Ready for the next mind-bending revelation? Neither are we, and that's what makes it so thrilling.